When x is positive 2, I'm going to get rid of a, and I'm going to get rid of b, and just solve for c here at the end. Okay? So, doing it that way, I'm going to have 2 squared. Whoops, let's make that look more like a 2 squared. Plus 12 times 2 plus 12. A is going to disappear, B is going to disappear. I'm going to be left with c. So it'll be c times 2 times 2 plus 2. Okay? Now we just work this out. So this is going to be 4 plus 24 plus 12 is equal to c times 2 times 4. That's going to give us, let's see, 3640 equals 8c. So c is going to be equal to 5. Okay. By the way, everybody, this is why you bring a calculator, because calculator can clean that up nice and quickly for you. Okay? Do the same exact thing with minus 2x, or x equal to minus 2. Okay? That's going to give us minus 2 squared, which is 4, plus, minus 2, or times, plus 12 times minus 2, which is negative 24. Okay? Let's make this clearer. 4 minus 24, plus 12. Okay? And then A cancels, C cancels, and I'm left with solving for B. So that's going to be B times negative 2 times negative 4. Okay? Cleaning that up here, this becomes negative 8. That becomes positive 8B. So B then is negative 1. Okay? Any questions about that? Nope. Fairly straightforward, right? Alright, and remember, proper way to write your final answer is to replace the original, the original fraction with these new numbers. So our big fraction at the end is going to be equal to minus 3 over x, okay, plus minus 1 over x plus 2, okay, plus 5 over x minus 2. Any questions about that? All right, good. Now, again, we saw this yesterday. We'll go ahead and review it again real fast today. If we wanted to check our answers, what we do, we can do it analytically or graphically. Doing so analytically means we would just add these fractions together and see if we get back what we started with. I'm not going to do that right now. We saw that yesterday. This is kind of long, so let's skip that. But we can instead do things graphically. Bring up our calculator. If we bring up the calculator here. Come on. Oh, you've got to kidding me. What?
God.
Oh my goodness, this thing all day has been just bugging the heck out of me. No, don't want to update it. Alright. You would graph the original function, like here, okay? There it is typed in. So that would be your first graphing option. Your second graphing option, you would graph your answers, okay? So it's minus 3 over x plus negative 1 over x plus 2 plus 5 over x minus 2. Notice my, my use of parentheses. You're going to want to use a lot of parentheses when you solve these problems, okay? And that just keeps everything nice and neat. It prevents the calculator, too, from reading this incorrectly.
Screwed up that much.
It can, actually, because the parentheses, without the parentheses, the calculator won't read these as single fractions. It'll read it as like 5 over x, then minus 2 on the outside of all that. So you'll get the wrong picture. Now, when I graph this, there should only be one picture. And indeed, if I turn off, if I, basically let's turn that one off, graph it. It's going to give me, here's the picture of the first one. Okay, weird looking graph, but that's the graph. Okay, no problem there. If I turn off the first one and turn on the second one, I should get the same exact picture. And lo and behold, what do we get? The same exact picture. Okay, everyone see that? Excellent. Okay, so we get the same picture both times, meaning that we did the partial fraction decomposition correctly. Yes.
Do we ever do this for the quiz on Friday?
No. No, the quiz tomorrow, quite honestly, it's one question, solve it for A, B. A and B. Like,
Oh, pop.
it's just
Oh.
really that fast. Okay. And again, remember, I'm mainly giving you this quiz not because, this is not a quiz as in, questioning your own quiz. This is more just, think of it more like a warm-up exercise. You're sitting down in class and just doing a problem.
A great warm-up exercise.
You're going to turn it in to make sure just so I know that you guys know what you're doing, basically. Don't fret. The quiz isn't here to count the same as homework grades. So, if you take this quiz, trust me, in the grand scheme of things, it does not affect your grade at all. Okay? Now, if you take every quiz, and I caught you not doing any homework, then we have a problem, but you're fine otherwise. All right, any questions on partial fractions here? We all good on how they work? All right, excellent. Okay, now we're going to go ahead and move on. And we are shifting gears here, okay? The other thing that's going to happen here is we're going to end up skipping around a lot for these next couple of sections. And it's simply just the way we're presenting this material, okay? It has to do with the way the book's laid out and what's important, what we need to know for our class, okay? But what we're going to look at today, this is all, it starts on page 511, okay? Section 7.4, and it's just the very beginning of the section that we're going to care about, okay? And what we're going to look at is something known as matrices. We're going to look at what a matrix is. Okay? Now, unfortunately, I can't tell you what the matrix is. You're going to have to see it for yourself. No, just teasing you. That's not. I'm not Morpheus. And this isn't that terrible movie.
Whoa. Terrible movie.
Actually, Matrix 1 is fun. Matrix 2 and 3 are.
They're all awful.
No, they're not all.
The only good part in the last two movies is the final battle scene.
The last movie is terrible.
With the Dragon Ball Z, them flying around and.
Yeah, the Sentinels flying around there, the mechs, and they're all
Yeah.
I don't know.
And the battle scene with the guy.
Yeah.
And there's 100 of him.
With the
It's-
guy.
The Matrix is. First Matrix, kind of fun.
Oh, no,
Campy,
the first makes it
but fun.
cool.
But in retrospect, it's really campy when you think about it.
Fuck.
Well, I mean, like, this is like hackers going to the net to like fight each other in some virtual world that looks like the real world, and like it's not how the internet developed at all. When you think about it, I mean, the internet now is like little pads like that.
Don't talk about Brendan that way.
So, anyway. Anyway, it's kind of silly, but what is a matrix, okay? A matrix in reality, or at least a matrix in mathematics, all it is a rectangular arrangement of numbers in a grid. Okay, so an example of what a matrix looks like, you would have like a line like that, and then you just have your numbers in this, rectangular grid. So it might be something like 3, 2, 7, 8, -1, 4, 2, 0, 6, 1/2, pi, 11. That's what all a matrix is, okay?
What?
Just a regular it's just a collection of numbers. Think of this as a grid. Okay, have you seen these before?
Yeah.
All right, good. All this is just a grid. You have rows across, so this would be like row 1, row 2, row 3, and then columns down. Okay? So So column 1, column 2, column 3, column 4. Okay? And that's all it is. So the matrix itself here is just an organization of numbers into this grid. Okay? And typically speaking, you use matrices. You use a matrice. It's going to represent something. Okay? What we're primarily going to use it for is to be the coefficients, to represent the coefficients of a multivariable equation. Okay? Because we can then do things with it to solve those multivariable equations. Okay? Fairly easily. But they could technically represent anything. Okay? One common use for them is in computers. Okay? My computer screen here. Okay? On my computer. Basically, the screen of your computer, you can think of it as actually a giant matrix, okay, with rows and columns, and the numbers represent basically the color value for whatever pixel the computer's lighting up, okay. Actually, there's 3 numbers in each location here, but that's just because it's telling you the red value, the green value, and the blue value, okay. But otherwise, that's basically how it works, okay. So when it changes a picture, it's taking a matrix like that and just changing the numbers in it, and that's going to correspond to the picture on your screen. Your calculator the calculator's display matrix works the same exact way. In fact, the proper name for this is a dot matrix display. Okay? Again, it's a matrix like this, except instead of being 3 values for colors, it's 2. It's either going to be a 0 or a 1. 1 meaning the pixel's on, 0 meaning the pixel's off, since it's a black and white display. Okay? That's sort of it. That's one idea of how a matrix works, or one use of them. Another big use, I used this example earlier. This is one, everyone has seen this and has used this type of matrix before. The box score of a baseball game is actually a matrix, okay? It's got 2 rows, one for the away team, one for the home team, and then the columns has basically 9 columns, each one for the inning scores, and then a final 3 columns for total hits, runs, and errors. Okay? But other than that, that is just a matrix. Okay? So, is there any crazy thing about a baseball box score? It's pretty easy to understand what's going on there, right? Oh, yes it is. Come on. Stop shaking your head, Virginia. Okay? Yeah, it's plenty easy. Okay?
I'm not a fan of baseball.
Yeah, but you at least understand what the numbers mean, right?
The numbers make
If there's a 2 in the 3rd inning column, what does that mean?
that means they got 2 guys.
They got 2 runs. It's all right. Don't worry about it. Here. No, they got two runs. Yes. Basically, so that's the whole idea. That's just an example of a matrix. Okay. There's lots of different things these things are used for, but that's sort of the idea there. Any questions on the basics of what a matrix actually is?
So it's just a random group of numbers.
Oh, it's generally not going to be random, but yes, it's just a group of numbers.
In our case, it's going to be
Well,
slightly random.
for right now, they'll be slightly random. Eventually, we'll be creating matrices with numbers and choices. Okay. So, like for example, one choice is if I go back to if I wrote out a multivariable equation here. Let's skip forward one. So let's say a multivariable equation has a matrix. Okay? So let's say I had a multivariable equation. Let's say I had something like 3x plus 2y minus z equals 4. Then 7x plus y plus 3z equals minus 2. And x minus 5y plus 8z equals 10. Okay? Let's say that was my multivariable equation. Okay? I could actually represent this thing as a matrix. Okay? Basically, the x's are one column, so it would be 3, 7, 1. Y's are one column, 2, 1, minus 5. Z's are one column, minus 1, 3, and 8. Okay? And so this here would be the coefficient matrix.